In this video, we'll go to the TCP/IP properties on a Windows computer to view the IP address, subnet mask, default gateway, and the DNS details. In our environment, we're using Windows 7. So to get to the TCP/IP properties, you need to make sure that you're under Network and Sharing Center. Once you're there, then we'll simply go ahead and click on where it says Change Adapter Settings. From there, we go to our local area connection that's plugged into our network, which is right here, and go to Properties. Now here, we go down, scroll down a little bit, to where it says the TCP/IP version 4, and select that, then let's go to Properties. So here's where we can define the actual IP address, the subnet mask, the default gateway, and the DNS. This is also where we can specify or enable DHCP by clicking on Obtain an IP address automatically, including checking this option to obtain DNS server address automatically. Furthermore, going to Advanced, we can look at details for adding additional IP addresses that we need to and other default gateways, but using one default gateway is recommended. So you will see that there as well. So basically, this is where you would go for looking at those details of how the IP address statically is configured, including its subnet mask and its default gateway and whatever DNS servers that are used in the environment. The IP details under the TCP/IP properties can also be viewed under the DOS prompt using the command ipconfig. If we want to view the IP address that is learned dynamically, we need to use that command. So the first thing that we need to do is go to a DOS prompt. So to do that, let's do that now. This is what a DOS prompt looks like. And we can type in ipconfig. Now doing that by itself, it will provide different options that we can do. We can do things like ipconfig/all, renew, release, and other components. But typing in ipconfig by itself, we can get the following details. You'll get details of all the interfaces or the network adapters on our computer. Now Windows 7 has a lot of additional stuff because it is also enabled for IP version 6. But let's scroll up towards the top. And here for one of our local area connections, which is right here, we see details of what we showed you from the TCP/IP properties list. We can see the IP address or the IPv4 address, the subnet mask, and even the default gateway. Of course, you will see the link local IPv6 address that we talk further in IC&D Part 2 about IP version 6. But that's some of the details you can get by using this command. Another command we can use here, by the way, let's scroll down, is ipconfig/all. Now this will provide additional information, like is it enabled for DHCP, what is the MAC address, etc. So let's go ahead and scroll back up to the same IP address that is configured on our computer. Let's keep going up. We got a lot of information here. Okay, so here it tells us the following. Same thing, but more information this time. We see the IP address that is configured, the mask, the default gateway, so we know that. We see the DNS servers that is assigned. We see the MAC address that's assigned. And it tells us if DHCP is enabled, which it is not, because we have configured this IP address statically. So this will provide additional details. And of course, the adapter type that we're using. So a lot more information. So use the ipconfig command if you want to obtain what is the IP address that has been learned on the computer automatically if DHCP has been enabled. So I tend to use this command more often compared to going to the TCP/IP properties on a Windows computer. To view the ARP table on a Windows computer, this must also be done in DOS. It will also show you how to use the ping command to test out connectivity to a device. So let's scroll down a little bit, make some room, and to view the ARP table, that command will be ARP-A. Now you have multiple networks on your computer, you'll get multiple ARP tables on your computer. But right here is the main ARP table that we have on our 106778 network. Remember, .3 is configured on our Windows 7 computer. So we see all these entries here of IP addresses followed by the MAC address that has been done dynamically using the ARP request and the ARP reply process. So this means that if my computer, which at some time communicated with the IP address of 1067.78.4. This is our NAS that has all of our files located at. Well, in order to talk to this IP address, it needed to obtain the MAC address to build that entry into the table, and it was done dynamically using that process. So this was done first before that communication occurred. And we see other entries as well for other IP addresses followed by their MAC address. So this is how you can use or how you can access to view the ARP table on a Windows computer. And we have the ping command, which is fantastic for confirming connectivity to a device. So that command will be ping followed by what you want to, check connectivity to. You can type in the IP address or a domain name. So if it's a domain name, we can check to see, can we access yahoo.com? So in this case, we do get a reply, meaning though it is responding. Now the main thing to look at is the total percent that is lost. Because 4 packets are sent. That's why we see 1, 2, 3, 4. A reply from this IP address, and we see even the latency involved, which is right here, 44, 36, 32 milliseconds. That's the actual time it took from our computer to reach their server and how they responded. So we can determine the amount of packets that has been sent, which is 4, and received. So it needs to be 4 and 4 to give a 0% packet loss. And of course, you see details of the minimal, maximum, and the average delay for that particular ping session that has occurred. What you also notice is that doing a ping and then the domain name or an IP address, but a domain name, for example, it will resolve it to the actual IP address that is associated to that domain, like yahoo.com. But also keep in mind that sometimes pings can fail. Now, if it fails, that doesn't mean necessarily that that device is not connected or there's connectivity issues to that device. It could mean that firewalls are blocking ping or ICMP traffic to that device, which is a best practice. You don't want to make an announcement that, yes, this device is available. You can access me for whatever services. You don't want to advertise that information out. And it could also be used for DOS attacks, for threats that could compromise this particular server. But Yahoo very likely has some kind of other security on their network, like Content Security's IPS, that can block various types of attacks. But this is what you can use for confirming connectivity to a device that is basically on the network, internal, or even external. Another tool to use is traceroute, which is used to learn about the path an IP packet takes through the network. So this is also done from the DOS prompt. So to do that, let's scroll down a little bit, and that command will be traceRT for traceroute, followed by the IP address or the domain name that we want to see the path it would take. So let's say yahoo.com again. Then let's do enter. So now it's going to determine the actual path, and we talked about what it does behind the scenes in the presentation video. So we see things like these numbers here, we see numbers in milliseconds, we see an IP address, some things are resolved to a DNS name, we see asterisks, we see something that says request timed out, and finally we get to the end of the trace route, trace completed. So let's talk about what's happening here. So we see that it took 12 hops, traveling through 12 IP enabled devices. That could be routers, that could be computers, servers, or even a firewall perhaps. It's anything that it went to that device, it checked its routing table and determined where it needed to go. So it likely went to a next hop or a next default gateway device. So you see the different hops that are reflected here that it took. Now most of these will be routers and firewalls, and the last device will be that destination host that we're trying to do the trace route to, which will likely be a server or a computer. Next, we'll see details of the average latency that it took to reach each particular IP hop along the path. This is good here because we can look at, like, this latency is pretty good, but at hop number 3, the latency is pretty high, 600, 800, 300 milliseconds to reach this hop. So if things are slow, using trace routes can tell us where is the latency happening at, which hop exactly for further troubleshooting. Some entries will have a asterisk here, or say request timed out, because just like ping traffic, trace routes can also be filtered as well by firewalls or other similar policies. And you see that based on the IP address that can be used, that my DNS server can resolve each hop using the DNS name that is configured. Well, this is good because this could tell me more information about that router. Like I know that this is going through AT&T's network, then goes to Yahoo's network. So this gives me a good idea of basically how is it traveling from point A to point B. So again, this provides information in terms of how or what is the actual path it would take to reach this yahoo.com server that we specify for the trace route. We also have the option of not resolving each of these IP addresses to the DNS name, which does take time to complete the trace route. So to do that, it's the same command, but we include a flag, which is -D with the traceroute command. So do -D, and doing that, it will not resolve the IP. It will still show us the actual hop numbers, the latency, but only the IP address of that next hop device. So you can see it's going by a lot faster. But again, I have no idea what these devices are. But that's what you can do to quickly speed up and give you your traceroute results, to know how did my packet go from point A to point B to reach that server. NSLookup is a tool used on Windows or Mac to determine the IP address associated with a domain name. For example, let's say that we want to do an NSLookup to yahoo.com to see what is the IP address associated to that domain name. So we'll simply type in NSLookup followed by the domain name, like yahoo.com. Now doing that is going to check it against the DNS server configured on our computer, which is right here. We're using the AT&T DNS server on our computer that's going to see and resolve www.yahoo.com, and it's going to respond with these addresses for yahoo.com. We also have the option of choosing maybe a different DNS server to resolve. So to do that, we first type in NSLookup by itself. And once we do that, we see the current DNS server that we're using configured on our computer. Next, we can define server followed by the DNS server we want to use for lookups. Let's say 4.2.2.2. Now that changes the DNS server selection. Now I can type in my domain name I want to do, like yahoo.com, to see what results basically come back from that DNS server. So very good for checking out different DNS servers to see how it resolves things. Not just external, but maybe internal. This is something I do very often when trying to confirm if DNS servers are working. Can a DNS server resolve a particular domain name? If it can't, then it's likely an issue with that DNS server or something with its network. So basically, those are some of the things you can do for using the NSLookup command for resolving what is the IP address with the domain name.